Now let's take a look at how we would dig into the packets. I'm just going to stop this capture here. And Wireshark is actually a very, very powerful tool. One thing that it does really well is that it breaks the packet up into its component pieces, and you can see that down here. Here's the frame indicator. So this is the very first frame in our packet, and it's telling me that it's 60 bytes, and that's what it captured. It says over the wire. This was actually over a Wi-Fi interface, doesn't much matter. We got 60 bytes of 480 bits. Now, here we've got the layer 2 header, which is our Ethernet 2 header, and we've got all of the components of that. And then finally here we can see that this is an ARP request. So this is the next layer up in the stack. It breaks apart all of the headers for us. And then not only does it do that, but it tells us exactly what each bit is. So if I select this right here, that's my destination address. You can see down at the bottom, it's actually highlighted 6 bytes there. So FF, 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 and so on. What Wireshark has done, it has taken those 6 bytes down here, and it has told us what those 6 bytes mean. First of all, that they're just FF, 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 and so on, but also that they represent the destination address. When I click the next one down, it says source, and I can see that we've got 74D435E03D49. That's the source MAC address. So you can see that Wireshark does a really good job in actually giving us some specific details. If I select a TCP message, I've got my Ethernet header again, and I've got my IP header. Now here is kind of where it gets to be even better. With a message like just an Ethernet header, very few details, easy enough to kind of figure out what's what there. There's really no translation involved. Here, though, we've got this, which is a half a byte, and that's the 4. And down, you can't see it very well because it's highlighted down here. There's a 4 there, and that indicates the version. The next half of the byte there is 5, and that says 20 bytes. So 5 is actually 5 4-byte chunks. So that's 5 4-byte words, and that's a total of 20 bytes. Now, you certainly could have done that math on your own, but you had to know what the 5 actually meant. Wireshark knows that, and it decoded it for us and told us that the header length is 20 bytes. Certainly, there's nothing in that 5 that indicates that's the header length field. That's really one of the values of Wireshark. If you don't happen to know the sequence off the top of your head for where all of the bytes are and what they mean within an IP header, Wireshark will figure that out for you. The other thing that I didn't mention earlier about the Ethernet header is that it's actually decoded that for me. So it's taken the first 3 bytes there, the 28CFE9, and it has converted that into an actual vendor name for me. So 28CFE9 belongs to Apple. So what Wireshark is telling me very helpfully is that we're sending this off to an Apple device, and the source is actually something from Hewlett-Packard. That's what the Hewlett P says. So it translates the vendor portion of the MAC address, the first 3 bytes, into an actual name, so we don't have to go off to a website and figure that out. Now, there are a lot of really handy pieces of information that Wireshark figures out for us. Certainly, if you want to go and look at the raw data, that's available down below. And if you select chunks out of the bottom portion, it will actually highlight in the pane up above what you're actually highlighting there. So if I did this 77, what I'm looking at is actually the timestamp echo reply field. And Wireshark has actually translated those hexadecimal bytes into a real decimal value. So you can see that we've got a lot of capability in Wireshark to really dig deep into the messages and figure out what's actually going on there.